We're continuing our section on money and risk. This video will focus on monthly deposits and payments. In our previous videos, we looked at simple and compound interest. In these situations, you're making a straight-up investment for a period of time or taking out a one-time loan with a single payment at the end of the loan. What happens more often in practice is that either you set aside money each time period and put it into an investment account to grow, or you repay your loan with installment plans. Installment plans are a part of virtually everyone's life. When we borrow money to buy a car or a house, the lending institution typically requires that we pay back the loan plus interest by making the same payment each month for a certain number of months. In the case where we're making uniform deposits, we'll use the formula shown here, where A is the amount accumulated in the future after compounding interest is earned, D is the amount of those uniform deposits, R is our interest rate, M is the number of times the money is compounding in a year, and T is the years of the savings plan or loan. For example, you deduct $100 from your paycheck at the end of each month and put into an annuity earning 8% interest compounded monthly. You continue these deposits for 5 years. How much is the account worth at the end of these 5 years? We have our formula. Notice that we're deducting $100 each month, so D is $100. Our interest rate, R, is 8%. Our interest is compounding monthly, so M is 12. And we're continuing the deposit for 5 years, so T is 5. Doing a computation using our calculator, we see that the amount worth at the end of 5 years is $7,347.69. Now, before we go any further, let's take a quick timeout for a discussion on calculators. Here is the equation that we had in the previous example. Now, the step-by-step that I'm going to go through is in the case where you have just a basic scientific calculator, and for a student who really needs to go step-by-step through a formula like this. For a student who has a fancier calculator, who's more comfortable with parentheses, then you can do this in a much slicker fashion. But I'm going to go step-by-step. So the first thing you would do is you would start with R over M. In this example, you would type into your calculator 0.08 divided by 12 and hit enter. Next, add 1. So type in your calculator plus 1 and hit enter. Now take care of the exponent, the MT. Type into your calculator the caret button, which will take you into the exponent, and then in parentheses 12 times 5 and hit enter. You want to be sure that 12 times 5 is in parentheses so that that entire quantity is in the exponent. Step 4, subtract by 1. So type into your calculator minus 1 and hit enter. Step 5, divide by R over M. So you would type into your calculator divided by parentheses 0.08 divided by 12 parentheses and hit enter. Now, be sure that the 0.08 divided by 12 is in parentheses so that you're dividing by that entire quantity. Finally, multiply by D. In this example, you would type into your calculator times 100 and hit enter. Your answer in this case would be $7,347.69. Here's another example. You have decided to save up for a graduation trip. You want to save $2,000 in 4 years. You find a savings account for which interest is compounded monthly at 5%. How much will you deposit each month to meet your goal? Here's our formula. Let's be a little bit careful. This time we know we want our eventual amount saved to be $2,000. So we know that A is $2,000. The question is asking how much we need to deposit each month. So we're looking for D. Our interest rate is 5%. Our interest is compounding monthly. We're saving for 4 years. And so therefore, our formula looks like this. Using a calculator, we compute the quantity in brackets and then divide 2,000 by 53.0148 to learn that we need monthly deposits of $37.73. Here's our formula for making uniform payments, where P is the amount of the loan needing to be repaid, D is the amount of uniform deposits or payments being made, R is our interest rate, M is the number of times the interest is compounding in a year, and T is the years of the savings plan or loan. Here's an example. You need to borrow $5,000 so you can attend college next fall. You get the loan at an APR of 6% to be paid off in monthly installments over 3 years. Calculate your monthly payment. Here's our formula. Notice that we borrowed $5,000, so P is 5. Our interest rate is 6%. Our interest is compounding monthly, so M is 12. And we're making these installments over 3 years, so T is 3. Using our calculator, we see that our monthly payments will be $152.11. It's time for a quick timeout for discussion on calculators. Here's what we had from our previous example. A step-by-step way to go through computing this formula is the following. First, we're going to start by computing the denominator. And in the denominator, we're going to look at that R over M. So we would type into our calculator 0.06 divided by 12 and hit enter. Add the 1, so type into your calculator plus 1 and hit enter. The exponent, which this time is a negative MT, so type into your calculator caret, and then in parentheses, negative 12 times 3 and hit enter. Be sure that negative 12 times 3 is in parentheses, and be sure that you're using the negative and not the subtraction button. Record this number. In this example, you'd have 0.0835644,919. Subtract the answer you found in step 3 from the number 1. So in this example, you would type into your calculator 1 minus 0.0835644,919 and hit enter. Record this number as your denominator. In this example, you'd have 0.164355081. All right, there's our denominator. Now we'll compute the numerator. Start with R over M. Type in your calculator 0.06 divided by 12 and hit enter. Multiply by P. Type into your calculator times 5,000 and hit enter. This is your numerator. The final step is to divide by the answer you found in step 4, your denominator. So in this example, you would type into your calculator divided by 0.164355081. Your answer should be $152.11. Here's an example you can try on your own. You're encouraged to pause the video if you like. See if you get the same answer that I did. Suppose you can afford a certain monthly payment and you'd like to know how much you can borrow to stay within that budget. In that case, you should use the companion monthly payment formula seen here. For example, we can afford to make payments of $250 per month for 3 years. Our car dealer is offering us a loan at an APR of 5%. What price automobile should we be shopping for? Here's our formula. Plugging in the fact that we can make monthly payments of $250, an interest rate of 5% compounding monthly, and a term of 3 years. We see that we should be shopping for a car that's roughly $8,341.42. All right, here's our last time out for a discussion on calculators. Here's the formula that we had in the previous example. And this is by far is our most complicated formula. As we did previously, we'll start by computing the denominator. So R over M. Type into your calculator 0.05 divided by 12 and hit enter. Add the 1. Now take care of the exponent, the MT. Multiply by R over M. And record this number as your denominator. In this example, you'd have 0.004839468. Now we'll compute the numerator. Start with R over M. Add the 1. The exponent. Subtract the number 1. Multiply by P. This is your numerator. Finally, divide by the answer you found in step 4. In this example, you would divide by the 0.004839468, and your answer should be $8,341.42. Suppose we need to borrow $15,000 at an APR of 9% to buy a new car. Let's first figure out what the monthly payments will be if we borrow the money for 3.5 years, and how much interest we will have paid by the end of the loan. First, let's compute those monthly payments. Here's our formula. We're borrowing $15,000 at an APR of 9% compounded monthly, and we're going to make these payments for 3.5 years. We see that we end up with a monthly payment of $417.67. So how much interest will we have paid? Well, the amount of money paid after 3.5 years, or 42 months, will be the amount of our monthly payment times 42. So the total amount paid will be $17,542.05. How much of that is interest? This amount includes the $15,000 that we borrowed. So the amount of interest paid by the end of the loan will be the $17,500 minus the $15,000 that we borrowed. So the amount paid in interest will be $2,542.05. But suppose we find that we cannot afford the $15,000 car because we can only afford a monthly payment of $300. What price car can we shop for if the dealer offers a loan at a 9% APR for a term of 3.5 years? This time, we'll want to use this formula. Plugging in all of our details, a monthly payment of $300, again an APR of 9%, and the term of a loan of 3.5 years. We see the price we should be shopping for is $10,774.11. One of the hardest things in this section can be determining which formula you want to use. Here you see the formulas for making uniform deposits versus uniform payments. The uniform deposits formula you're going to want to use if you're saving up for an amount A in the future. So you're making uniform deposits so that you can save up to go on a trip, to buy a car eventually, to do something in the future. In the case of uniform payments, you're going to use this formula if you're paying off money already spent. So you borrow money to buy a car. You've spent that money, you've bought that car, now you're paying it off. Or you take out a loan to pay for college. You spent that money, now you've got to pay it back. So that's the difference in the two formulas. Are you saving up for money in the future, or are you paying off money that's already been spent? That's all for now. Thanks, guys.